I'm proud to introduce ElizabethK.Joseph with Linux on-prem, cloud, or mainframe.
Okay, so first of all, if anyone was at my talk on Monday, there is a little overlap in slides, just because I have to explain what a mainframe is during every single one of my talks. So you're gonna see those slides again, but most of this is really focused on open source, so I'm gonna be talking a lot about open source software with regard to the mainframe. A little bit of an introduction. I've been to LCA 5 times. This is my 5th one. And over the years, I've done a lot of talking about my work on Ubuntu, my work on OpenStack, doing a lot of CI/CD stuff. And the last time I was here, I was working for a container startup in San Francisco. So doing a talk on mainframes is like way out of left field, right? This is very strange. And it was very strange for me too. I joined IBM about 8 months ago. And when they were interviewing me, because I was looking for a job, they approached me and they said, "Hey, you want to work on mainframes?" And I was like, "No." But I talked to a bunch of people in the organization, a bunch of the engineers, and unbeknownst to me, mainframes are still being made. They're releasing them every 2 years over at IBM for the most part. They're doing all this innovative stuff with caching on the CPUs and other things I'll be talking about. My role at IBM is as a developer advocate. I don't know how much a mainframe costs. I don't know how to sell you one, and that's not what I'm here to talk about. Mostly what I'm here to talk about is my journey over these past 8 months, learning what they are and learning about the really cool stuff going on in the open source community surrounding the mainframe these days. And mostly I'm a systems administrator. I spent 15 years in the industry working at small companies doing deployments. I ran web servers for museums and mail servers for shipyards and all kinds of things in the US. We had lots of buzzwords in my sysadmin world, distribute and cloud and CI/CD, doing a lot of OpenStack stuff. And in this journey that I had as a sysadmin, starting in the 2005 or so, the question was increasingly being, do you want to do this on-prem or in the cloud? And in these discussions, it was just x86. Like, there was no other architectures really being considered. At home, I had a Spark Ultra 10 that I played with, and a bunch of other weird hardware. I still have Raspberry Pi, so I was playing around with alternate hardware. I also ran a mail server on a Sun Cobalt machine, which would have security vulnerabilities that wouldn't be patched for months, and that was terrifying. So I played with alternate architectures, but at work, that was just for fun. Like, at work, it was all x86. There was no question of what we were going to be using. But there are these other architectures out there. So right now, Hugh is giving a talk on Power, and I'm so sad I have to miss it. There was a bunch of talks about RISC here at this conference, and then IBM Z, the mainframe. And if you look, when you download software for open source software, it's S390X is the architecture that's referenced. So there is this world out there of all this other stuff. Oh, ARM, that was the first one I listed. Like, that's huge. Like, Raspberry Pi is ARM, our phones are ARM. Like, they're all over the place. So they're out there. And I was like, we should probably start considering these in our infrastructures. But the first question I'm going to answer is what a mainframe is exactly. If you'd asked me a year ago what a mainframe was, way over there, 1964. That's what I would think of. This big room with big noisy machines, people dressed nicely, and working on computers that were big and obsolete and old. This picture is one of the press promo things that came out in September 2019 when the Z15 was released. That was the latest mainframe that IBM made. And this is like the 4-frame one. This is like the super decked out, awesome one just sitting in a data center. And so they're actually modern, and they're actually much smaller than they used to be. But depending on who you ask, a mainframe is a bunch of different things. So they fit into a 19-inch rack these days, so they're much smaller. But then you can expand them up to 4. I have these little stickers. They're little partying mainframes here. 4 of them. And so traditionally, the operating system they run on is ZOS, and I'll talk a little bit more about the operating systems in a minute. But increasingly, the biggest market segment for growth is running Linux. They're really, really good at data processing. You might understand batch processing, like when your bank turns off for the night and does all the transactions. That doesn't really happen anymore so much, but it was a thing of old. You have amazing enterprise-grade hardware and storage that's like tested to withstand earthquakes. So this machine, it doesn't go down. Like it has withstood earthquakes, like in real life. I'll talk a bit about virtualization in a minute, but things like virtualization and networking, things that I ran into a lot when I was working on OpenStack and Mesos and other distributed systems. Like, we would have a project, a project would take 8 months, right? And then we'd run into networking problems, and we'd run into storage problems, and then the project would take 18 months. These are problems that are solved on the mainframe. So when you're deploying an infrastructure on one of these, it's actually a lot simpler. If you crack one open, this is what they look like inside. So up at the top, you've got these support elements, and that is how you interact with the mainframe. So that'll be typically connected to like a Lenovo that's like attached to the mainframe to interact with it. It also calls out to like external controls, so you don't have to be in the data center to deal with it. You got your gigabit Ethernet switches at the top. PDUs, those are the power. In the middle, there's no good color to write on this graph thing here. But CPCs, those are the central processor drawers. And then a bunch of I/O cards. So these are like PCIe cards that interface and do I/O processing to make data processing super fast. It took me forever to get this picture because I couldn't find pictures of the internals. And people are like, why do you care what it looks like? You're not like using it. I'm like, that's cool, right? I want to see hardware. And most importantly, like, I think it's really important, it's not x86. So if you are using this, you need to recompile your software. And whereas almost everything we use these days is little endian, the mainframe is the last one out there that's still big endian. So that does trip up some software, but it's not so bad. In a fully decked out mainframe these days, you have 190 processors. They have 12 cores per chip. They're the fastest commercially available ones at 5.2 gigahertz. But also, like, in the machine, the fully loaded one can have 40 terabytes of RAM, and you can read all these specs. But, I mean, these are really massive machines. And you'll notice I don't mention, like, hard drive space on here. And that's because the machine is all just computing power. You attach it to external storage. So the coolest, fanciest, most awesome one is the one that came out a few months ago. And they all have crazy names, DS8900F. The F means it's all flash drives. So this one is just a giant machine full of flash drives totaling 6 petabytes, which is crazy. And if you buy that, you're very rich. But that one like checks all the boxes. Like, you want low latency and high throughput and like everything. That's when you buy these. And then there's like all these rack mount options. And then you trade off like cost and speed and what you want to access. But all of these, like, these are crazy fast enterprise storage. And so like you don't have to deal with playing around with MDADM and other things. You do have to do specific things to storage to make it persistent and things inside of Linux when you set things up, but that's getting a bit out into the weeds here. It's all still easy stuff, but this solves a lot of problems that I ran into with storage over the years. And of course, that means you're dealing with proprietary storage backends, but sometimes it's worth the trade-off. I mean, I'm a hardcore open source person, so like, it's sad for me to leave behind the world of Ceph and other things, but like, if you're not a storage company, sometimes this makes sense. And that's kind of the point of my talk, really, is that you should weigh these options. And like, I didn't know mainframes still existed, so when I was a sysadmin, like, I didn't even know that I should consider these things as options in my infrastructure. So, I'm not gonna read this whole slide because it's silly. I'll post the slides online later. But essentially, like, ZOS is the traditional operating system for the mainframe. You've got your ZVM, which I'll talk about, and then these other like purpose-built ones. But what I'm really here to talk about is Linux. And these modern mainframes, they run Linux. And they have for over 20 years, which was a surprise to me. I had no idea. So as a fun experiment, I decided to research this and figure out what the history looked like. So first of all, when I say it runs Linux, it actually runs Linux like on top of a logical partition, which is like a thing on a mainframe that you install things on. That's like an isolated little area. So you can install it directly on it, just like you would do with ZOS, or you can use ZVM or KVM these days to run it as a virtual machine. And so it's pretty much like native on the mainframe at this point. But history-wise, I decided to go way, way back in time. I was like, where is the start of virtualization in our world? And so I started talking to some of the people that were not quite around in the 1950s, but the ones who were around like soon after that and involved in the virtualization technology that was developed in the 70s. And they told me that the CTSS was kind of like the dawn of time sharing, and time sharing is like the father of virtualization. So in 1959, there was a white paper published, and then 2 years later at MIT, they actually were running a demo of the compatible time-sharing system on an IBM 709, and that's what that is a picture of. Fast forward a few years, 1972, the IBM 370 came out. The IBM S360 was the first mainframe, so the S370 was a little bit later than that. But with the S370, this VM 370 came out, and that was really like what we can call the first virtualization software anywhere. And so there was this really interesting story of IBM and the community and like how they related to each other. So the first like computing organization ever was founded in 1956, and it's called Share. And they developed the first operating system that ever existed, Share OS. And IBM was like, oh, that's good, we should use that. So they did. So Share OS, developed by the community, and then adopted by IBM and moved on to that. So the Share user group community, which still exists and has conferences multiple times a year, they worked in tandem with universities and large companies that were all using mainframes to essentially develop what was open source software. It just didn't have that name yet. And they were sharing software amongst themselves, and they were working with IBM, and they were saying, we want virtualization. And there's this whole history that I linked to in the bottom here by Melinda Veranden about like this whole history like of all the milestones, virtualization, who was working on what was failing, what was working, what IBM was doing, what IBM was not doing, and what the community members were doing. But VM 360 was pretty much a turning point. And then they had a bit of a rough time. IBM was not convinced about virtualization, so they called this the doubtful decade, where there wasn't a lot of work being put into it on the IBM side, where the community was stepping up and being like, we really want this. We want to run multiple things at the same time. We don't want everything to be really slow. But it gets better. So in the late 80s, this decade ends and IBM's starting to get on board, and they're like, yes, virtualization is awesome. And then with regard to Linux, in 1994, experimental TCP/IP support ended up in the ZVM. It wasn't ZVM yet, but the VM software for mainframes. And that was like a huge component in later supporting Linux. But looking at it from the mainframe side, TCP/IP was just another networking protocol that they were adding support for. They didn't know at the time that this was actually going to take over the world and drive the internet and change everything for us. So in 1998, there was a community group that got together and they wanted to run Linux on the mainframe. So they started this project called Bigfoot and started releasing their first patches in 1998. And there's this really great GeoCities-esque website here that explains some of the history of what they were working on. But in general, what they were trying to do is like, they were a bunch of nerds, and we can recognize this list, at least the top four, right? Like, we're like, the top four, that's really why they were doing all of this, right? Like, it's a stunt, they wanted to learn, because it's there, right? And then you get like more serious as the list goes down, but I think they just added those on later, like, oh wait, it's got really fast I/O. Virtualization is cool. And you can check out their list and a few other things on this link here. So this work that they were doing on Bigfoot started getting out there in the community, and IBM's like, oh, actually, we've been working on this. So at the end of 1999, so just over 20 years ago, IBM released their first patches to a 2.2 kernel that would add mainframe support to the Linux kernel. These weren't mainlined or anything. These were just like patches that you add onto your kernel when you compile it yourself. So it still wasn't quite, a finished product, but they did land the patches and at least made available to the community. So with that, Red Hat sort of started picking things up. SUSE was actually SUSE Enterprise Linux was the first proper distribution that landed on the mainframe. A few months later, Red Hat ended up with a distribution on it as well. And my favorite story about this is if you look at SUSE's history, technically, SUSE Enterprise Linux was on the mainframe first. And it was SUSE Enterprise Linux because it was on the mainframe. So I like to say that SUSE on x86 is the port. It's all just branding. It doesn't actually matter. It doesn't mean anything, but it's funny anyway. So why did IBM want this? So their reasons were actually the last four in the nerd slide, right? They actually were thinking about diversifying using virtualization and the fast I/O. And this is a funny commercial from 2001. It's funny, not funny, but kind of dorky funny. And I won't play it for you now, but it's about data center consolidation. So they replaced everything in their data center with a mainframe, and this guy's freaking out and calls the police and security and says, everything's gone. And it's oh, it's on a mainframe. And it's e-servers running Linux. And I'm oh, 2001. But it's fun if you have a chance to look at it. But IBM, there was a real business interest here. So when IBM released their patches, the tech internet got really excited. And this was a really sad slide to put together because most of these sites are gone now. But Internet Archive. So what has happened in these past 20 years? So the networking has gotten a lot better. So instead of communicating through TCP/IP, the VMs communicate using these hypersockets, which is a mainframe thing. For storage, you connect to these devices, and storage has been something that's been highly developed over the years because it's actually a hard problem to solve, and Linux and storage on the mainframe didn't automatically just work magically together. There's been a lot of innovation in that space over the past 20 years. Processor-wise, Linux can run on just the regular mainframe processor, but they also have a subset of that processor called the IFL, which is the Integrated Facility for Linux, and that's a Linux-specific processor, which just means it can't run ZOS. It's only for Linux. And so some of the instructions are disabled that ZOS might use. And open source has become a big deal in the mainframe. Which is mostly what I'm going to be talking about for the rest of this talk. But if you want to look at a full list of all the open source software that's been ported and validated for Z and mainframe, that's a link there. But first I want to talk about encryption. So this is kind of a blown up picture of what we saw before. So again, these can come between 1 and 4 frames. So this just happens to be a 2-frame example. So you've got your CPC drawer. That's where the processors live. And then this green thing over here is one of your processors. So the processor has crypto coprocessors inside of it. And then you've also got a crypto express card, which comes out of your PCIe drawers, which there was I think I said there were 12 of them. A bunch of drawer drives. So the crypto express card is your HSM. It's the most powerful one on the market. And then your crypto happens with your CPU. So when you're doing cryptography and encryption on the mainframe, it doesn't actually take away from your general processing power, which means they're really, really good at encryption, and they're super fast. And how it's used on Linux was one of the things that I was really excited about before I took this job. So I was asking them, what do you use for an encryption? And he's oh, dmcrypt. I'm oh, I know what dmcrypt is. And things like OpenSSL, libcrypto, this is just a photo from one of the red books talking about how to enable OpenSSL on the mainframe. And it's really just adding a config file. You're not adding weird binary blobs, you're just going in and editing it because it's actually just part of the source code. So this has all been added upstream to support the architecture in OpenSSL. So that means you can use Apache mod SSL, that automatically all going to hardware. IPsec, that's all going to hardware. And there's also built-in encryption in Java and Go, and that's all going to the hardware if you're running it on the mainframe. So you're not using your general processing power for this stuff. They're also open sourcing a lot of their libraries. So there's libICA, and that's an open source project that handles some of the encryption libraries. So getting back to sort of our history lesson, IBM released their Linux-only mainframe in 2015, and that's called a Linux 1. And they've been refreshing it every 2 years so far, and so in 2019, they released the Linux 1.3, because they hate me. Okay, so the story here is they used to name them after penguins, so there was the Linux 1 Rockhopper, and the Linux 1 Emperor, and then there was the Linux 1 Rockhopper 2, and the Linux 1 Emperor 2. And then with this release, they decided to drop the cute penguin names. And one of my colleagues was like, it's great, I always got them mixed up. I was like, how can you get them mixed up? You know, the rockhoppers are little penguins and emperors are big penguins. And they're like, Liz, not everyone knows about penguins. It's obvious, right? Anyway, so like having a Linux-only mainframe is just one of those like pivotal moments that's really exciting. Like this means IBM has made this serious investment. They've designed cases. So like if you saw earlier in my presentation, I don't know if I had any of the blue ones, but like the ZOS and the traditional ones, they're blue. The Linux ones are orange. So like they're a different color. They have different branding. They have different all kinds of things. And of course, different processors, because you can't run ZOS on this. This is only Linux. And they run lots of open source software. So this is kind of like our vanity slide of like, look at all the stuff we've ported and validated and shown works great. And this is actually a really, really large chunk of stuff. And so one of my first questions upon joining was, we're so proud of all the stuff that's been ported to this architecture. But what does that mean? Like when you say you run Red Hat, does that mean you've recompiled the entire repository of Red Hat Enterprise Linux and now that it runs on the mainframe? Not quite. But they did recompile a huge portion of the repository. Same with SUSE and Ubuntu. I think Ubuntu still has the most packages of them all. But what they do essentially is they recompile them and they see if they work and pass their CI tests. And if they do, they ship the package. Some of them they do further, like all the ones here have actual further validation, like the ones off of the distribution list. Like these are all validated like by IBM and with the project in collaboration. So they're not just rebuilt and shipped. But the distributions themselves, like when I first did this, I installed a chat client and screen. So I was like, okay, well, those work, cool. And also, if you have open source software, there's also opportunities for you to build things for the mainframe. So first, okay, this slide. This is the least IBM-y they would make it for me. I'm like, I can't say unleash the power to innovate. Who says that? And then I said, can you just at least put penguins on it? So here we are. Anyway, the important thing is this link on the bottom, which is actually really cool. So this is the link to our like developer site, and that will get you, if you follow that and, I don't know, give us gobs of your personal information, well, you will get a free Linux VM on the mainframe for 120 days. If you are an open source project and you want to see if there's open source software builds on it, you can reach out to me. My information's on the slide deck and on the internet and everywhere. And I can work with you to get a VM that's longer lived and you can add to your CI system and stuff. But this is fun because you can log on and you can like cat your CPU info and show it to people at parties. I'm really fun at parties. So anyway, like, I mean, I don't know what else you do with it. I mean, you try to see if your software compiles. You can install a few things and see how it's running. It's cool, and like mostly it's like, I have a VM on a mainframe. That's nice. It is based out of a college in New York, so the latency from Australia, I actually haven't logged into one from here, so it might be a little slow, but. And this is really hard to see, doesn't matter. So there's also a few other ways you can build your software on S390X. So Ubuntu, they have a build system on Launchpad.net, and they allow you to build for a bunch of different architectures. So if you create a deb package, which is what I did here and I wrote about in my blog, I just created like a simple like hello world Golang application. And then I created a deb package, which was actually the hardest part of this whole process. And then I uploaded it to Launchpad, and it's just like a checkbox, like build for S390X, check. And then the CI system goes off and builds it for it. And I was like, oh, that's cool. And then I was able to use my free little VM, and then like download the deb package and make sure it works. And I was like, it works. So this is free. You have to agree not to do horrible things on Launchpad, but you know, anyone can do this for free. So that's Launchpad for building deb packages. SUSE also has a build service. I'll be honest, I don't know how to use OpenSUSE build service yet. I've been trying to find time over the past few months, but it's really hard. And I'm like a Debian Ubuntu person, so I knew how to make a deb, but using this build service is tricky. But the cool thing about it is they build for a bunch of different architectures automatically. So no checkbox here. It'll build for ARM and Power and S390X automatically, and they build for a bunch of different operating systems. So this will build RPMs and debs for Ubuntu and SUSE and Red Hat automatically. So yeah, it's really cool. This, again, free, but there's a learning curve. One of the things that we were pretty excited about in November is Travis CI now has access to a mainframe. We gave them a bunch of VMs. And so now you can test Power and IBM Z on your open source project. So if you're using Travis, it's just an addition to your config file. And then you can build your packages and run your CI stuff on the Travis CI pretty easily. And so the title of this talk was talking about whether you go like in the cloud or on-prem. It turns out it's not actually something you have to decide fully. IBM Cloud has some mainframes in it, secretly. It's not really in our marketing material and stuff because the marketing folks don't like the word mainframe because it plays poorly. So like we've got these hyper protect services. So there's a crypto service which allows you to use an HSM on a mainframe. There's a database as a service which offers like MongoDB and Postgres inside of the mainframe, so it's all encrypted. And then virtual servers. So this is virtual server. I think all three of these you can actually get like a demo instance of right now. So the virtual servers is again like a VM on a mainframe, and I think we have a free tier at the moment. So you can play around with a version of Ubuntu that's all like heavily encrypted and only you have access to it. One of the other things that's pretty cool is the components of the IBM blockchain platform are also running on the mainframe. Because if you were to design a machine that was purpose-built to do blockchain, it would probably look exactly like a mainframe. And that's very lucky for IBM. But I mean, blockchain is essentially like doing data processing and doing crypto. And that is what a mainframe is really, really good at. So it's made sense to build your platform on this. So we have customers who are building their blockchain platforms on mainframes, and some of them are using the cloud service that IBM offers. So if you want mainframes in the cloud, they exist. We also have Kubernetes. I gave a talk about this at KubeCon a couple months ago. And it's really weird because people think of Kubernetes and distributed things, and then they think of the mainframe, and they think of them as two totally separate things. But all the major distributions are working on things. The SUSE link is especially fun because it's actually just a tutorial on using kubeadmin. And then at the end of the tutorial, it's like, we did this on S390X, but you can do it on x86 too, right? And then, of course, Red Hat, like, okay. If my employer had my way, like this whole talk would be about OpenShift, but only one link, okay. So OpenShift is coming to Z. This is an article talking about some of the plans. So OpenShift will be able to run on the mainframe. There's this really great Ubuntu blog, the Ubuntu on Big Iron blog, and that has a bunch of really highly technical articles about running various things. This one happens to be about running the canonical distribution of Kubernetes on the mainframe. So they have like this whole platform for running Kubernetes, and they've ported it. There's also like small companies who are doing work on it, so like OpenShift Origin. So if you go to one of the Linux on S390 mailing lists, like the guys from Assigned Nominee, like they pop up all the time if people ask Kubernetes questions because they've done all the open source stuff to make OpenShift Origin work. I've also worked with this company in the Netherlands, ICU IT services, and they're pretty much just working on integrating like old ZOS environments with like new cloud environments, and they're using Kubernetes to some extent to do that. And the idea here is that they want to run their workloads on the cloud and on their x86 machines and on their mainframes using all the same tooling. And Kubernetes fits that bill because on the mainframe, you can run KVM. You don't have to use ZVM, so you can use KVM as your underlying infrastructure for virtualization, and then you can run your Linux and your containers on top of that and use all the same Kubernetes tooling. And the Kubernetes ecosystem is really big and growing, so Kubernetes was like the sensible answer for running containers on the mainframe. There's also being work done on ZOS to run containers inside of ZOS, so you can run Docker containers inside of ZOS now with the latest version of that. Like sort of just have a consolidated container environment regardless of what you're running on, cloud, x86, whatnot. And then we're getting back into the ZOS land. So I wanted to touch upon this quickly just because I've been doing a fair amount of work with the Open Mainframe project. So the Open Mainframe project is essentially just a bunch of open source folks and companies who got together and realized that open source is taken over the world, and we want to bring that to the mainframe world. So one of the big projects, that pretty much their flagship project is Zoe, and Zoe is an interface to the mainframe. So this is how you traditionally interact with the mainframe. It's scary looking to new developers. I'd be fine with it, I think. I've played around with it some. It's actually not that hard. It just takes there's a big learning curve. But ISPF, that's pretty much how you interact with all of your stuff. But the learning curve was pretty steep. So one of the things that they came out with the Zoe project is a web desktop. So it opens up in your web browser. It looks like a desktop. You can open up like your batch jobs, you can edit your code, you can do all kinds of stuff and explore your mainframe system through a graphical interface. You can make edits with this, and all it does is hook into like an API that interfaces with the mainframe, and then it uses this graphical interface. And I was like, all right, that's cool, but like I don't use graphical interfaces at work. This is neat for exploring and for learning new stuff. But the real power, I think, came from having a CLI that operates like a bash CLI, essentially. It's like a shell, because mainframes, they do have like a Unix service and have for a long time, but the Zoe CLI makes it more modern and more consolidated, so there's a lot more you can do with the Zoe CLI instead of breaking it up with various tools in the mainframe. So you have a Linux terminal, you run Zoe commands. If you go to this link here, you can see some examples of like using the Zoe CLI to edit a data set, like just for example. You can also do cool things with the CLI, like there's a visual code extension now that allows you to edit mainframe code using this. And also, like most importantly, you can use this to add things to your CI/CD pipeline, so you can script things really easily, which is something that was pretty challenging before. And then the API is pretty much what all this is built on. So the CLI system uses the API, the web UI uses the API, and that's pretty much like the core of what Zoe is. So, sort of coming to the end here, I'm leaving some time for questions, I think. Yeah, I got plenty of time. So looking into the future of why we should care about these things. When I was learning about the history of all this stuff, I have a colleague, Paul Newton, and he's one of these mainframers who loves to tell stories, and I love to hear stories. So we were having a chat about some of the older stuff, and he was telling me like what he thinks about the future of these things, and he's like, the world can't take us building all these server farms for x86 machines. Like there's so many of them. They're being built in the US where I'm from. Like they're building them really fast, and it's getting a little bit crazy because the power consumption is insane. Sorry, like just outrageous. But I was like, oh, like they cost too much, or are we killing the planet? He's like, yes, both. So one of the things that he was seeing like in the future is we need to start paying more attention to energy consumption because we've been really lax about paying attention to that. So we keep building bigger and bigger data centers. And they tend to be geographically located in places that make sense. So places that are near water powered or that are cold. But at the same time, like power consumption is becoming more important. So that's why I think why we're seeing the growth of things like ARM, because ARM is lower power. But with mainframes, you can also consolidate a lot of your workloads. So you need fewer mainframes for the number of x86 machines you need. So the energy savings there is important. There's also been a lot of data breaches in the past few years. And so as we see more laws come into effect about personal data and companies actually getting into trouble when they lose data, I sort of see this future where encryption is becoming more important. There's various numbers out there about how much data is actually encrypted, but the number that tends to pop out is like 4%. Only 4% of our personal data that's hanging out by companies is encrypted. And they try to encrypt the important stuff, but as we all know, you can associate data with people even if it's been somewhat anonymized. Did I lose my mic? Oh, there we go. More laws and regulations. I think like California is about to pass like GDPR type rule about personal data use. And as I mentioned sort of in the beginning of the talk, like we're seeing more architectures getting more attention in the space. So I think that's going to keep happening. Like it's not just going to be an x86 world anymore. I sort of see this future where there are data centers running ARM and data centers running more mainframes. And one of the stats that I heard was really interesting was that we sold more mainframes in like 2018 than we did in 1990. So they're not going away, and they haven't gone away. So I think hopefully as companies get less shy about sharing information about their mainframes, we'll see that popping up more. Because I actually reached out to some of the sales guys in Australia for IBM. I was like, are there any customers I can talk about? And they're like, no. But I'll let you in a secret. If you search for jobs on mainframes, you can figure out who's using mainframes. So just to wrap up, essentially like the title of this talk is a false dichotomy. You don't need to choose whether you're doing on-prem or in the cloud. One of the big strategies is like hybrid cloud. So diversifying your workload across your mainframe and your cloud work and whatever else. Using something maybe like Kubernetes so you can use a consolidated tool set across everything. But you don't need to choose. You can use a mix of all of these things. So any questions? Comments? There's one back there.
Hello. When you're submitting software to those build systems by, was it SUSE?
Yeah, and Ubuntu.
Yeah, the other one. Are they compiling it on a mainframe?
Test.
Anyway, other questions? Hey, it's green again. See how much time we can get out of this. Anyway, yeah. So Canonical and SUSE and Red Hat, they all have mainframes in their organization. So that's how they build RHEL, and that's how they build Ubuntu. And then Ubuntu and SUSE have given that portions of that to the community. So it does take a little longer to build the mainframe binaries, at least on the Ubuntu one. I think just because the community is deprioritized, makes sense. Yeah, they actually have mainframes. Questions? Comments? Stories?
The self-provisioned VMs, they come in SUSE and Red Hat, but not Ubuntu and Debian.
Yes, so they don't come in Debian because there's no business relationship there that IBM has. The situation with Ubuntu is we are not allowed to release modified versions of Ubuntu and call it Ubuntu on our cloud. And we have to if we're running on ZVM. But we are rebuilding our cloud onto a Z15. It's currently on a Z13. We're rebuilding our community cloud onto a Z15, and we're going to use KVM, which will allow us to use unmodified Ubuntu, and then we'll be able to offer free VMs for that. In the meantime, you can use the HyperProtect virtual services in IBM Cloud, which is like a totally different thing and totally different set of mainframes. If I'm honest, like the community cloud was kind of like my team getting together and being like, IBM Cloud is slow and we can't get anything done, but we need to offer something to someone. So we just like partnered with the university and started offering VMs. So people are like, how can I pay for this? And we're like, there's not a pay thing, it's just a thing for fun for developers. So also that means the SLA might be a little low. Like if you have trouble with your VM, you're like essentially emailing some like overworked developer who can help you fix it eventually. But just keep that in mind.
Yeah, hi. You mentioned something about the power consumption. Is it possible to have jobs moving around? Supposing I had a job or set of jobs, maybe compute intensive, and they had to be spread out like, I don't know, genomics jobs or something. And could you spread that around so that it would run on the cheapest available node in the, wherever that is in the world? So if it's winter somewhere, that might be cheaper than summer here,
Right.
based on power consumption.
Yeah, so that's kind of the promise of Kubernetes, is that if you containerize all of your workloads, then they're really easy to move everywhere. And that is kind of the idea here too, is like, if you can come up with an algorithm that can judge things like the cheapest place to run it, then you compile your workload as a container on S390X and a container on x86, because Docker supports alternate architecture. So Docker doesn't care where you're running the image, as long as it does actually compile. So yeah, I'd say you could use Kubernetes in a way that can move things around. I don't know of anyone who's doing it necessarily, or at least who's been public about it, but that's totally doable, since if you're using containers, you can just move them. It's not something really inherent to the mainframe, though. It's just All right, one more?
So I've heard stories about legendary mainframe reliability and how you can hot swap CPUs and whatnot. Do you have any more like interesting points like this that makes it different from just a bunch of 100 x86 PCs?
Yeah, so as you say, the CPUs are hot swappable because they overload them. So they put more CPUs than you actually use. They put more of them in here. So when one dies, another one just pops in. And you get like an IBMer with one of these machines. They'll come out and like swap out hardware parts and stuff, so they can swap out the CPUs and stuff. But I think there's pictures of natural disasters where the mainframe survived. So there's one where it like fell through a floor, like it fell through the floor onto the next floor, and it was mostly okay. In Japan, after the Fukushima situation, earthquake and tsunami, one of the mainframes was still running when they went to the data center. Like, everything was dead, and they're like, what's that noise? So like, and there's a video on YouTube, if you Google like mainframe earthquake, that you can see how they test them over in Texas. Like, they raise it up on this platform, and they just like shake the machine like crazy, and they see what falls out. And so then the earthquake tested and stuff. So not only can you like hot swap a lot of the components in this, and every time something's not hot swappable, everyone's really apologetic. They're like, I can't believe this isn't hot swappable, right? So most things are, but also like they legit can like handle natural disasters and stuff. So it's pretty cool hearing the stories out there. And those are just the ones I can talk about. So, yeah. So, all right, thank you everybody. Penguin dinner.